In this video, I will be solving a stoichiometry problem using an initial, change, and final table method. So, the question asks, when 25 grams of K2C2O4 is reacted with KMnO4 according to the following chemical reaction they have right here, and they've given us the molar masses of each substance in grams per mole, just below. So, it first asks how many grams of KMnO4 are required for this reaction. So I'll start by doing this question. So A. So the first thing that we want to do is convert this 25 grams of K2C2O4 into moles. So 25 grams times its molar mass, which is 166.2. And this gives 0.15 moles. Okay, now that we've done that, we can make the table. So I'll make the table starting over here. So in this table, initially we have 0.15 moles of K2C2O4. K2C2O4 right here. So I'll place it right underneath the K2C2O4. And then we want this to react to completion, so we can say that it fully reacts, and at the end, or final, we have 0 moles. This table stands for initial moles, change in moles, and final moles. Okay, so the first question asks how many grams of KMnO4 are required for this reaction. So to do this, we need to know that for every 5 moles of K2C2O4, we have 2 moles of KMnO4. So in our change in moles, essentially what we have to do is write a ratio. So for every 2 moles of KMnO4, we react with 5 moles of K2C2O4. So 2 over 5 like a fraction, and we react 0.15, we have 0.15 moles. And we want this to go to completion, so we want to have 0 moles at the end of this reaction. And this is subtracted because this is reacting. We're losing reactant. So we don't know how much initially, but we know how much it changes because of the moles that were given at the beginning. And because of the ratio, we can determine how much it changes by. So given this, when we multiply these two together, it gives us 0.06 moles. So we can say initially we had 0.06 moles because after this calculation, 0.06 minus all of this, which is 0.06, we get 0 moles. So initially we have 0.06 moles of KMnO4, and it asks us how many grams. So 0.06 moles times the molar mass, which is 158.04, gives us 9.5 grams. So for question A, that's the answer, 9.5 grams. Okay, for the next question, it asks how many grams of magnesium hydroxide will be produced. So this is pretty similar to the first question. So the first thing that we want to do is start with the initial change and final table. So we know initially in our product we have 0 moles of magnesium hydroxide because we have nothing there. We're producing that in the reaction. We have nothing to start off with of magnesium hydroxide. So we know that we're producing it, so it's a plus symbol. And we know that looking at the coefficients, magnesium hydroxide is a mole coefficient of 2. So we can write a 2 there. And we're comparing it with the K2C2O4, and that has a mole coefficient of 5. So we can write it as 2 over 5, just like this one, except it has a positive symbol. So we multiply that by the initial moles of K2C2O4, because that is what we're comparing with here. When we multiply this together, this gives us 0.06 moles. So in this reaction, we are producing 0.06 moles of magnesium hydroxide. And to determine the amount of grams that we are producing, we just multiply it by its molar mass. So the molar mass of magnesium hydroxide is 88.96. So 88.96 grams per mole. If we multiply this together, it gives us 5.34 grams. So that's the answer for question B. Okay, for question C, it asks us, if the reaction is done in 2.5 liters of solution, what will be the concentration of OH minus at the end? So it's asking us what is the concentration of the OH minus right here at the end. So to start this problem, we can write, we know that there is no product to begin with, right? That's what we're creating. So in a change, it's a positive number again. And for the ratio this time, it's different because for every 12 moles of KOH being produced, there's 5 moles of K2C2O4 being reacted. So instead of 2 this time, we have to write 12 over the original amount, the original ratio, which is 5. So 12 over 5 times the same number though, 0.15 moles. So if we multiply this together, we get 0.36 moles of potassium hydroxide. So it asks us if the reaction is done in 2.5 liters of solution. So all we have to do is do a calculation. So 0.36 moles, all we have to do is we have to divide that number by the 2.5 liters of solution, because we know that molarity is in moles per liter. So this will give 0.144 molar. So that's the answer. So that is the concentration of OH minus at the end, 0.144 molar. Okay, the last question asks, if CO2 is collected and its density is 1.98 kilograms per meters cubed, how many liters of CO2 will be formed? So let's do that one next. Actually, I'm going to erase this first. I don't know why I didn't erase that to begin with, but I'm going to erase that. Okay, so to start this one off, we know that CO2 is a product, and we start with 0 product, as always. And since it's a product, we know that the change is a positive value, so we put a positive sign there. And the ratio of CO2 to K2C2O4 is 10 to 5, so 10 over 5, so 2. 10 divided by 5 is 2. So we still use that same amount of moles, 0.15, and when we multiply this out, this gives 0.30 moles. So we know in this reaction we are producing 0.30 moles of CO2. Okay, so now what we need to do is we need to determine the amount of grams of CO2 we produce. So 0.30 moles multiplied by its molar mass, which is 44.01 grams per mole, and this gives 13.2 grams, and we want this to be in kilograms instead of grams because we want to be able to cancel with the density, because the density is in kilograms per meters cubed and we want to eliminate the kilograms. So we're going to change this from grams to kilograms. 13.2 grams divided by 1,000 because we want to convert this to kilograms. This gives us 0.01 132 kilograms. Okay, now that we have it in kilograms, we can multiply it by the density. So 0.0132 kilograms multiplied by its density, which is 1.98 kilograms per meters cubed. So we write it like this, so that the kilograms will cancel, and all we'll be left with is meters cubed. And this will give 6.67 times 10 to the minus 3 meters cubed. But we're not done yet because the question asks us to put it in liters, not meters cubed. So we have to, well, we should know that 1 meter cubed is equal to 1,000 liters. So all we have to do now is multiply this value by 1,000. So if we multiply this value by 1,000, 6.67 times 10 to the negative 3 meters cubed by 1,000, this gives us 6.67 liters. And that's the answer right there.